Hello and welcome back to module number 2 in visual analytics. We are going to do the first class was introduction to the subject of visual analytics, but now we are going to dig in and start looking at what does it means to talk about visual analytics, and not only talk about visual analytics. Today we're going to learn firsthand about a basic tool called Fusion Table by Google, and we will be able to produce something that later on in module number 3 we are going to make it a little bit prettier, a little bit more transparent, in order for us to communicate what we aim to do. But I would like to start this module with a little bit of a review of what we have discussed so far in module number 1. We talked about that visual analytics has a lot of definitions. It's not one specific definition, it has a lot of definition. But one of the things that we are when we are talking about visual analytics, and our free textbook by Ellis and Manson talk about, is application of visual analytics. So today we are going to see that in the form of Fusion Table and Google Analytics, and see how it play out. So let's start. But before we will start, I need to say something about design. Design, unlike text, is not a very clear black and white. We do not have terminology, a straightforward terminology like we have in alphabetic or in grammar, that we need to follow the grammar rules in order for us to produce something meaningful or something that people will be able to understand. So what do we have in visual analytics? I will try to break it down to the following points, or to the following items: points, lines, coordinate system, numbers, symbols, words, shading, and colors. And that's according to Professor Edward Topfi, and I will talk about him later on this class, his contribution and what he brought into visual analytics with regard to the history of visual analytics. He collected a lot of history maps, and in order for them to communicate, he found things that they all share. So the first element of any visual analytics is the point. If there is only one point, one mark on a blank page, there is something built into the brain that generates meaning out for it. Or in this case, probably you have your own interpretation. So we are looking for seek type of relationship or order in order for us to provide us more structure to what it stands out. A line is also a mark by moving a point and having again some physiological input according to the direction, the weight of the line, the variance of the line, and then the direction of the line. And again, it gives us some sense what it is trying to communicate. So in this example, we see a lot of lines, but what does it really mean? What can we take out of it is something that we need to think about. Circles, the same thing. They represent something, and we will apply circles and lines and dots in our visual analytics, but we need to start thinking about what they stand for. Why is it important for us to consider them one of the elements, the basic elements of visual analytics, in order for us to communicate what we want to achieve? Text, of course. Text is what we are accustomed to read. We read the newspaper, we read the textbook, we read a lot of things, and text can give us some structure, but again, it has the same principles or the same element as the line, as the dot, or as the circle, and it represents something that our brain try to comprehend and try to achieve. We also see in visual analytics a lot of patterns in the visual display. And those patterns are something that we need to start accommodate and start to see it and start to pay attention to it, because it is another dimension how we tell the story, how do we convert what we want to convert in the visual analytics. And of course there will be colors, and colors will be one of the subjects in our upcoming class, and we will talk about the colors and what they represent. And again, it's a lot of to do with culture. Culture, example, we see culture and the type of color they like. Example, the people from the north like warmer colors in compared to the people in the south that like more light colors. So again, the issue of colors play an important part. But we also have format that we usually associate with visual analytics. Example, bar chart. Example, line bar, line chart, and pie chart, scatter plots. All of that is quite easy to produce if you are familiar with Excel. So simple bar chart is most common type of visualization, and it usually display on different quantities of a single variable. Example, how many times a day do I drink coffee? So I drink 20 cups a day, but twice a week I drink more. And so this is a way for us to distribute the amount of coffee I drink and present it in a that will make more sense to the outside, to the user outside. There is also the line graph, and again, this is the most popular platform, and usually we see that with banks or with stock market, and they will show you where the stock market goes, and it's supposed to be very direct because we have a background, we have axis X and Y, and they will tell us exactly where to point and where to see things. And this coordination grid allowed us to be more specific with regard to what we want the user to see in our data analysis. There's also a pie chart that is also very common, and it's usually help the user to understand. And again, in this case, distribution of a city or a county money distribution, where it goes, most of the money usually goes to the police or the fire station, and the rest goes to public works and financial aid and parks and other services. So again, how they display it, is it readable? I have my doubts, but we will see how we can improve that. How can we make it better? Scatterplots, again, is a very popular platform, and it shows the relationship between different type of data sets. And one of the biggest assets when we will learn about open source R is the ability to differentiate between the different data sets with colors in the scatter plot and be able to show how those two data sets relate, and what they present. But Microsoft Excel, and that's one of the reasons that I do not like Microsoft Excel, is it's a little bit limited. A bit limited with regard to the visualization it allowed us to produce. It doesn't allow us, for example, bubble chart. It doesn't allow us ring chart. It doesn't allow us to show distribution maps or counter maps or heat maps. All those things are part of visual analytics in order for us to convey, to display more information in more than one dimension. And it's important because nowadays data is big, and data science in specifically deals with multiple set of data. So we need more platforms in order for us to make sense what we are trying to display. Ring chart is very popular. Microsoft Excel does not allow us. We will learn how to do that in Plotly and in open source R, and you will see how easy it is. We will learn today to generate a map based on Google Fusion Table. But before we will go to the Fusion Table and what is it consist of, I want to start talking about statistics, because Visual Analytics talks about or discuss about statistics. Show me the numbers. One of the textbooks that we are going to read throughout the semester, and I'm going to talk about that today, is about statistics. It's about what we can provide. The analysis of statistics can tell us about the data and how can we convert it. And usually in statistics, we are talking about two types of statistics. Descriptive statistics that aims to allow us to have a collection, representation, and description of the data. Usually when we do descriptive statistics, we are talking about the entire population. And inferential statistics is how can we draw decision or draw conclusion about the population by taking a sample. A sample is a small proportion of the population. Example, in the last election, the night before we voted, they made the prediction of who is going to be the next president. Those are based on inferential statistics. So, example, a recent study examined the math and verbal GRE scores of high school seniors across the country. GRE usually is for undergrad studies, students who want to go to graduate. This time they provided to seniors, high school students, and they try to understand what does it mean. So the mean math score was 492. And the mean verbal score was 475. So in this sense, it gave them perspective how college students will be able to score and what score that they will have in order for them to see what is the average and how to improve that. So 80% of the students taking the exam were headed towards graduate school, and 32% of the students score above 610 on the verbal GRE score. So the math score was higher than previous 10 years. And they do that randomly every time. So introduction to basic terms in statistics, and we will count that every time then. In our textbook and even in our examples. We are talking about two types. Population is the entire population. Example, when we are selecting a president, it is the entire population that goes to select the president, and a sample is taking a subset of the population and make predictions about the entire population. This is really important to understand, because this will give you better sense why is it so important about sample versus population. We also talk about variables. A variable in statistics is a characteristics about each individual element of the population or the sample. Example, when they take a sample who see how they voted, they usually are very concerned about the variables. Are they man or woman? They have a college degree? Do they have a job? Do they drive a car? Do they have a high school diploma, etc., etc.? All those components, sex, education, smoking, not smoking, is a variable. Data is the value of the variable associated with one element of the population. The value may be a number, a word, or a symbol. In Perl, the term data means that the set of values collected from the variable for each element belong to the sample. Experiment is a planned activity whose result yield a set of data. And we have two types of statistics. We have the idea of statistics values, which is numerical values summarize the sample data, and we have the other type, which is numerical value summarize all the data of the entire population. We will talk about that, but we will not focus on it. Our idea is to take those type of data or type of variables and try to visualize it. So, an example, a college dean is interested in learning about the average age of faculty. So, he needs to identify the population, he needs to identify a sample, he needs to identify a variable such as age, he needs to have at least one data that would be the age of a specific faculty member, and what will be the statistics and what will be the average of all the college and versus the average of the sample. This is really important because that will give him a better sense or her better sense of what is the numerical value or descriptive value of his faculty. We're talking about two types of variables usually, and this is a classification of the variable. We have qualitative or attribute and or categorical variable. A variable that is categorized, describe element of the population. Example, age is a categorical data. You cannot be age 27 and the age of 51. You have to be one of them. And we have quantitative variable that is qualified as the element of the population. Example, the color of the skin. I am white and you might be different. I cannot be white and a different color at the same time. So this is the things that we are looking at type of variables and how to do that. According to our textbook, when we attempt to make sense of quantitative data, more than anything else, we examine the variation. So qualitative data exhibits several types of variation, such as qualitative and categorical, and they may try to make sense out of it. And we will see example throughout the semester. We will see example of it, and I will come back to it as we go along. So an example, the resident hall for each student in statistics, it is attribute. It is the attributes of the students. The amount of gasoline pipe by the next 10 customers at the local Walmart store. This is numerical because every customer can buy different things and different amount. The amount of random in the basement of each 25 homes in new development. Again, this is attribute. So you see that there is difference between attributes with regard to variables and how they apply that. But again, we will talk more about that. I want to move on to the visualization aspect. And visualization, we are thinking with our eyes. What does it mean? According to our textbook, again, I refer to a few, 70% of our body sensor and our knowledge comes from the eyes. So human vision is connected to our brain, connected to our cognition, and this is how we make decisions. We have to see things in order for us to make decisions. We read. Reading is part of what we do with our eyes. The eyes is part of how we see the visualization. So it is an essential part, and it has to have influence how we see visual perception. And again, we have a great example here. We have a table and we have a graph. Who make more sense to you when you're looking at that and try to understand what's going on? Most of you probably will say the visual, because the table consists of more numbers and it's a little bit more confusing. And if you have a lot of numbers or a lot of tables, that might be a little bit more complicated to achieve in compared to the visualization that we can see exactly where the man versus woman stands and how it be applied. And in today's database, we have a lot of sets, we have a lot of data scales, and it's really hard to understand what is going on. So our eyes are our main components, our main brain, how we perceive or accept or see things, and we need to recognize it and to apply that just to make sure that we communicate well. So how visual perception works, there is basic issue that we need to discuss here. Figures versus the background. In this A and B example, you see that there is a figure in both terms, A and B. But in figure B, there is a line that covers the figure, which makes him stand out. By doing that, by using the line as a ability to pull away and be able to make a distinction between what is the background and the figure itself, make the work better for us with regard to perception. What about ambiguous images? When we can see a lot of example of that in visual, when we go to the museums, there's a lot of ambiguous images. They are part of the things that we need to accept and see where they're taking us in order for us to do that. So perspective, the issue related to the figure, the ground in the following is the following. Sometimes visual things are something ambiguous, and so is the picture in this slide, is it of a young stylish woman or the older woman? We do not know, because the creator of this visual, of this picture, did not give us the details that we are looking for. In any visual school, they will teach you about Gestalt laws. Gestalt laws is looking for patterns in the visual display. What is a pattern? Example, when you write an essay in English, we are talking about how you apply grammar in order for it to make a voice to yourself. Present tense, past tense. In the Gestalt law, we are looking at pattern perception. How do we make those perception or patterns in the visual that will make sense or will give us a pattern inside the visual? I hope it makes sense. Let's see example. When we are talking about things that are close together, they seems to us as grouped together. So the rule is the best way to emphasize relationship between different type of entities is to place them in approximately in a display. An example, what works best for you? The first example to the left or the first example to the right? And if it to the right, when you have A, B, and X, and you see the proximity, you have better sense what's going on in compared to the example to the left. Similarities is the same element, have the same shape, colors, and they also group together. So the rule, according to the Gestalt rule, is that related visual elements should look similar in order for them to make a point. Example, A and B. So in the example B, you see a patterns XXX or circle, circle, circle. Those are the circle that we are looking at and our brain like to recognize in order for us to make more meaning out of it. The difference between A and C and A and B is that in this case is that the difference between the X and the circle is much more clear when compared to the A and B, where the difference is with colors. Another way is to construct visual grouping of the elements, and by applying the connectedness, which is stronger than approximately. Use connectors to show relation. Example, again, A, B, and C, and show the connection, how they relate to each other. The example C does not show you good example, but example A is a good example, and example B might be something in the middle. So good example, again, this is a good example how we can make things connected to each other. A, B, C, and even D, even though they are not the same elements in the end, but they are still connected using a line that makes them connected. There's also the idea of how we are using symmetry to relate to visual elements. So again, this is examples of it. This is the structure of it. Our textbook talks about that. And again, I want you to make sure that you understand that. And again, the issue is to show the layout, to show the layout of the entire set in order for us to make sense. Closure is another element. We use closed regions to segment the visual space, group similar elements. An example of a closure, and again, A versus B, and I hope that you sense that A is a better closer than the B, and why is it so? Relative size, and again, similar components of a pattern tends to perceive as an object, and again, this is part of how we see things and how to figure out things. And figures and background is really important. The combination of the law to segment image to fit into the figure or the background will help you to make more sense out of it. People also see counters where they don't really exist, but it allowed us to illustrate some patterns inside of it. What makes better, A or B? Some would argue there is no difference between them, but a lot of people will argue that B is much better because at least it has some consistency with regard to its present, even though in the general face that you see it almost look the same. Transparency is another way for you to see, is the color correspond to existence? Is it matched to the existence? And we will see example of that. So again, part of the Gestalt rules and how to understand it. Overlap is, again, we use that all the time in Photoshop when we lay one layer to another, and it again, the overlapping of the visual object allowed us to give us patterns, give us ideas what stands out of it. Patterns in motion. We will see in the end of the semester, we will see example of how to generate motion over the web. And we will see the difference between frames. And so we will see how it the idea of the effect of the motion give us the notion, or give us the sense, or to our brain give us the sense that there is continuous motion in the object itself. So we will see how it play out and what does it really means. The forms and the counter in motion, and we will see that too. Moving frames, we will learn about frames, we will learn how to apply them and what does it really mean. Causality is also part of two movement that depends on between two different sets and how to apply that. And again, I'm running here. I know that I should stop and talk about each specific things, but this is the syntax that we will go over again and again throughout the semester. I want you to start becoming all those vocabulary together in order for you to understand what it is. And causality is one of them. Is there causality between the data set? What is the causality? There is a statistical causality calculation. What does it entail? animate motion. We will learn about that. Human, when we are going to the movie or when we see animated movie, humans are very good in perceiving motion. So how do we see that? How do we play with it in order for us to communicate better what we have found? And we will talk about 3Ds and what does it mean to have figures, 3D dimensions into it. This principle of repetition is also key elements. Repetition is key components, and I will try to show you an example from the past and nowadays throughout the semester about repetition and how it plays out. So a good attribute for a good design is from the size, the shape, the enclosure, the blur, the colors, the position, the motion, and that's from our textbook, page 39. And he shows pre-attributes, example, what is very precise, what is not very precise. How can we make sure that we are trying to be very precise on what we visualize? As I said before, design and visual is not a scientific science. It is more something that we use, but we do not have a vocabulary, we do not have grammar to analyze everything, and so you're going to develop your own grammar, your own terminology in order for you to do that. So the building blocks of information science is first of all, the learning about the result, trying to do that information with regard to visualization. We will learn about reasoning, and we will learn about how do we persuade and how do we communicate with visual object and visual properties. In chapter number 4, few talks about layout, and he gives us 13 principles of layout, relationship between data. He talks about comparing, he talks about sorting, he talks about editing, filtering, highlighting, zooming, and we will learn how to apply that with regard to visualization. So the comparing, orange to apple, how do we compare that? How do we make sense that when we are comparing oranges versus apples, what does a good visualization has to offer to make it more transparent? Is it the colors? Is it the additional attributes that describe what it stands for? Will those make the comparison easy? Sorting the data is another element. You want to arrange a list of names in alphabetical order in order for you to have from the highest level to the lowest, or the order from the row by columns or icons. Example, all the green colors who are stated in 1963, and all the gray was not counted. So again, this is part of sorting the data and trying to display it that will be more transparent to everyone else. Adding variables is another dimension. We did not define yet what is it. We talked about the variables in the beginning. We talked about categorical variable, we talked numerical variable, but a variable is a characteristic number or quality that can be measured or counted. And in data analysis, we are looking for more interesting attributes. So in this sense, wind versus temperature, we are adding more attributes or more variables in color of the red line, the green line, and the blue line. Those give us something else, give us more information about that, and it can be, example, the day of the month, or the time, or anything else that might give us additional information in order for you to understand the data better or to understand the analysis better. Highlighting it make it possible to focus on a subset of the data while seeking in the context of the whole. And again, this is something that we will learn about. Example, in this example is budget and the average. And so those are the components that we will see. And as you can see, we have two variables here, action and another variable. How do we apply that? How do we tell a story out of it? Data aggregation is another element that is usually used, such as age, professional, or income. And pre-expressing, what is the re-expressing can save the day? What is the relationship? What does it mean? How can we sometimes change the way we deliberate data? Can we examine it to better fit our model? So we are usually using revisualization to stick with it, and according to Fay, according to our textbook, the revisualization of the data can help us better understand the data itself. And I will talk about all those components throughout the semester. This is, again, I'm introducing you, I'm giving you some ideas what does it entail, and I will show you an example, but throughout the semester, I will repeat it. Zooming in and panning is another dimension that nowadays is very popular. And it's used to provide a closer look at the data. I gave you an example from RStudio with the idea of the Shiny. And in this case, I can provide the ability to look at the data and be able to give attributes to it in order for us to have better example or better sense what it is. Scaling is another dimension, and we will talk about that. I know I'm talking about a four-dimensional of about nominal, ordinal, interval, and ratio. This is how we usually organize or classify or analyze the data. So the idea that our textbook talks about is scaling measurement techniques of the scale, and by doing that we can influence the scaling of the visualization. Assess the details, provide more details on your visualization, so the viewer will be able to understand the visualization better. And so again, this is example. If you will give more information inside the visualization, will help the user to understand that. To the right, there's only 1, 2, 3, and to the left, there's the red, blue, green, and brown, which give more sense to the user how to see it. Bookmark is, again, at the time of this book was written, the idea of bookmark was a terminology. So it shifted, and now we are talking about bookmarking with regard to our browser. We're talking about what it entails. It is an open term. We will go back to it later on, but I want you to have that idea and what does it entail. So I cover 13, I know I covered quite a lot today. I covered 13 classification of how we use, types of data and convert it in order for us to make it easy to visualize it. The comparison is one of the preferred way to do that. Sorting the data, adding variable, filtering, all those components are part of any statistical analysis, but using the visualization can help us to sort that. And so we will learn how to apply that. We will learn it through different application that we will see. So I want to move now to the pragmatic aspect of this class, and we're going to talk about geographic information. What is geographic information? Is giving the data with regard to the geographic location. So example, in your phone, every one of us has a map that if we are getting lost, we can find the direction back home. So human likes the idea of that, but in a sense, we are also involved in it visual analytics. What colors? What is a road represent? How do we mark a road. What is it? Mark a path, a safe path compared to a dangerous path. So all of it is part of the geographical information, and geographical information is very visual by itself, but this is not the point of the class. What I want you to take out of it is how they apply the software application and use the colors to create patterns, to create trends, to create explanation with regard to the maps, to the graph, to the data, and to the text to make it more transparent. So what is Google Fusion Table? Google Fusion Table is inside the browser. And we will look at that, and I will give you an example how to do that after my slide. And so you will see that it allows using Google search to search for data that Google will be able to apply the Fusion Table. And by doing that, you will be able to create the idea of the data, and the next step will be to create a map. In this example, I collected data from Florida public libraries, and it helped me to generate a map, all the libraries' location on the map in Florida. As you can see, there are a lot of libraries, but this is a tool for us, and it's a geographic tool that allowed us to do that. Next class, we will take this output and we will use a more advanced graphical interface to make it more concise, to make more transparent, because right now we have dots and it doesn't tell us anything. We will need to add to it more attributes to make it more transparent. So how do you create a Fusion Table? I will have that in the PowerPoint presentation will be available to you to look at. You have to log on to your Google Drive, and your Google Drive, you're going to create on the new, after they will play all the commercial, you're going to create new, and you're going to search for new forms. And if you will see all those forms, you will say connect more apps. And in this case, you're going to say Fusion Table. And you're going to search. And you're going to say connect. And he will connect to it, and it will be available to you to use inside the Google Drive. So in this case, the Google Drive will come here. So you will open, and this is the interface. You can use a Google spreadsheet, or you can use public data tables, example, public libraries, or I will say ice cream shop in Tampa. And if I will search, you will see that it will list it for me all the ice cream, soft serve ice cream shops that they have data on in Florida. There will be two options here. One, export it to Google Sheet, or export it to Fusion Table. I will say export it to Fusion Table. So when you open it, you will open the Fusion Table. You will have store name, address, city, state, and zip code. You will do some editing to it. You will change not the address, you will change the address to location. And you will say the city will do the same thing. And you will save it. And he will mark that the address and the city will be added. You can generate a simple visualization, but my point is that I want you to add a map to it. So he will start thinking about how to convert this data into a map that will show all the ice cream shops that are available in Florida. It will take some time, but in the end, you will be able to generate a map out of it. So okay, that's what he found. So he found only that, and usually it's only in Miami, has more shops of ice cream. In Tampa, there's 2, and in Miami, there are more. This is my example. You can search any topic that you like, and you're going to save it. You're going to save this image, and you're going to save that image by choosing all of it and clicking and save the image, took a picture, and you will save it. You will save it in your hard drive. You will pull it and post it on your blog, and by doing so, you will be able to create the next time. We'll take it with a more advanced statistical, more advanced application. You'll be able to apply that and be able to apply that to more concise application. So I lay out for you exactly what you need to do, how to do it, how to change it, and your assignment. You will see everything in your blog, and you will submit it to blog. So until next time, please, you will have a lot of material to work with, and I will continue to update the canvas so you'll be able to understand and be able to reach out to create this visualization. Until next time, have fun.